Good morning children. In numbers and sequence, now we are going to solve exercise 2.8. In previous class we have completed exercise 2.7. Newly we started geometric sequence, isn't it? I explained what is geometric sequence. What is a geometric sequence? A sequence, if the sequence has a common ratio, then the sequence is said to be the geometric sequence, isn't it? 2.8 also related to exercise 2.7 only. There we studied about the geometric sequence. Here in exercise 2.8 we are going to solve the geometric series. Okay. Series, it is not new word for you because in arithmetic series means just the sequence. If you are adding the sequence, the terms of the sequence, that is called as the series. So that is not new for us. Here we are going to learn about the geometric series. Yes, geometric series means the terms of the geometric sequence. You have to find the sum of the terms of the geometric sequence. That is called as the geometric series. So here the general form of geometric series. What is the general form of geometric series? A plus AR square plus AR cube etc. up to n terms. Here we are going to add the series, geometric series, then we are going to find the answer. Okay, for that we are going to use some formulas. With the help of the formulas we are going to solve the problem. Okay, what are they? Already we know this. What is A? A is always the first term. Okay, A represents always the first term of the given series. R is the common ratio. Okay, here we are going to find the sum of the series, sum of the geometric series. For that, what are the formulas we are going to use? The first one, Sn is equal to A into R power n minus 1 by R minus 1. Sn is equal to A into R power n minus 1 by R minus 1. Okay, this first formula, second formula, this formula is used for the geometric series only to find the summation. But in different case, okay, in different case, both the formulas are going to use to find the summation only, but in different case. How? This formula, the first formula, you can use only when the common ratio is greater than 1. We can use this first formula when the common ratio is greater than 1. If the series is given for you, we will find A and the common ratio. If the common ratio value is greater than 1, if you are identifying the common ratio value is greater than 1, you have to use this formula to find the summation. What is the formula? Sn is equal to A into R power n minus 1 by R minus 1. The second, Sn is equal to A into 1 minus R power n by 1 minus R. This formula you have to use when the common ratio value is less than 1. This formula you have to use when the common ratio value is less than 1. If you are finding the common ratio is less than 1, then you have to choose this formula. Sn is equal to A into 1 minus R power n by 1 minus R, and you have to add the given series. Okay, some special case to be there. Now for the third formula, Sn is equal to A into m. If the common ratio for any geometric series, if the common ratio is exactly equal to 1, then directly we can use the formula Sn is equal to A into m. Then we can find the sum of the series. Okay, this three formula 1, 2, 3. These three formulas are used for finite geometric series. If the geometric series is given as a finite geometric series based on the common ratio, if it is less than 1 or greater than 1 or equal to 1, based on that we can choose what is the suitable formula and we can find the summation. In case if the geometric series given as infinite geometric series, if the given geometric series is infinite, you have to use, we can identify what is A and we can identify what is the common ratio also. We have to use the summation formula as Sn is equal to A by 1 minus R. Especially if the series is infinite series, you have to use the formula Sn is equal to A by 1 minus R. So these are the basic formulas you have to keep in mind to solve this exercise. Okay, let us solve the exercise now. So see the first problem in this exercise, children. The first question is find the sum of first n terms of the GP. They gave the GP here. We have to find the sum of first n terms. Is what is the GP given in this question? 5 minus 3, 9 by 5, 27 by 25. No need to check with the common ratio whether it is GP or not. Already in the question they gave that it is a GP. So directly you can use the formula and you can find the summation of the GP. So see what is the geometric progression here? 5 minus 3, 9 by 5, 27 by 5. What are the A. The first term. What is A? 5. The first term is 5. And what is the common ratio? How we will find the common ratio using the GP? Using the formula T2 by T1. So what is the second term here? Minus 3. Minus 3 by 5. Minus 3 and 5 cannot be simplified, so keep as it is. The common ratio is equal to minus 3 by 5. Check the common ratio R is less than 1 or greater than 1. Minus 3 by 5, the value is less than 1 or greater than 1. It is less than 1. So here the common ratio is less than 1. We have to find the summation. So we have to use the summation formula. If the common ratio is less than 1, what is the formula we have to use? Sn is equal to A into 1 minus R power n by 1 minus R. We have to use this formula when R is less than 1. In the given question, the R, in this case, the R is less than 1. So out of the 3 summation formulas, you have to choose Sn is equal to A into 1 minus R power n by 1 minus R. Okay, S. Now we know the value from the given sequence. What is A? 5. So 5 into 1 minus, what is the value of R? R is minus 3 by 5 whole power n. By, in the denominator it is 1 minus R. So 1 minus, what is R? Again minus 3 by 5. Minus 3 by 5. After substituting, we have to solve. Just there are numbers falling out. We know how to solve the numbers. Just do the calculation and solve it. How? See, 5 into 1 minus 3 by n. Sorry, minus 3 by 5 whole power n. Without knowing this power n, what is the value of n? We can't take this minus. Okay, we can't solve this minus r 3 by 5. So keep the numerator as it is. Come for the denominator. 1 minus of minus 3 by 5. So minus into minus and now it will become plus. Minus into minus will become plus. So 1 plus 3 by 5. 1 plus 3 by 5. Now, what's the value? The remaining we are having the numerator 5 into 1 minus 3 by 5 the whole power n. In the denominator, if you are taking the LCM and adding this, the answer will be 5 plus 3. It is 8 by 5. If I add the denominator, it will become the value of 8 by 5. In the denominator, there is a fraction. So the final answer, just take the reciprocal of the denominator value. If I take the reciprocal, 5 into 5 by 8 into 1 minus 3 by 5 whole power n. So if I multiply 5 by now, 25 by 8. 1 minus 3 by 5 the whole power n. Okay, so this is the final answer. Without knowing this power of n value, we can't solve it. Okay, we can't solve 1 minus 3 by 5 whole power n. So keep as it is. Only the solving part, whatever the numbers possible to solve it, get the final answer. So the summation of the given geometric series is 25 by 8 into 1 minus 3 by 5 whole power n. See the next problem. Find the sum of first 6 terms of the GP. We have to find the sum of first 6 terms of the GP. Okay. Here they gave the GP again. They mentioned that it is a GP, isn't it? So 5, 15, 45, etc. is a GP. Is you have to find the sum of first 6 terms. That means summation you have to find. What is the A in this GP? What is A? 5. And the common ratio. Common ratio is T2 by T1. That means 15 by 5, the answer is 3. So, whenever you are finding the summation, adding the terms of the GP based on the value of R, only you have to use the formula. If R is less than 1, greater than 1 or equal to 1. You have to identify it first, then choose the appropriate formula and substitute it. Here, R is equal to 3. So, R is greater than 1. R is equal to 3. R is greater than 3 is greater than 1 now. So R is greater than 1. So what is the summation formula we have to use? Sn is equal to A into R power n minus 1 by R minus 1. This formula we have to use when R is greater than 1. So in this case we have to use this formula. Sn is equal to A into R power n minus 1 by R minus 1. So what is n? How many terms we have to find? First 6 terms. So the value of n automatically 6 minus 1 by what is R? 3 minus 1. Now find the value. We are having 5. What is the value of 3 power 6? If you multiply 3 power 6 times 3 into 3 into 3 6 times, the value is 729. If I multiply 3, if the value is 3 power 6, if I expand it, the value is 729 minus 1 by 2. Isn't it? How to solve further? Is see 5 into 728 by 2. 5 into 728 by 2 because 729 minus 1 will give you 728. So if I simplify by 2, the value is 3, 6, 4. 3 are 6, remainder 1. So 6 are 12, 4 are 8. So finally we have to multiply 5 into 364. 5 into 364. If I multiply the values 1820. If you multiply the values 1820. So if you continue like this, the GP, if you are adding up to the 6 terms, the final answer, the summation of the 6 terms is 1820. Okay children? So see the next problem, third problem. Find the first term of the GP whose common ratio is 5 and whose sum to first 6 terms is 4, 6, 8, 7, 2. What is given in the question? This is the GP. We are speaking about the GP here. Whose common ratio? For the GP, the common ratio is 5 and they gave the sum of first 6 terms. If we add the first 6 terms, the value is 46,872. 46872. That's the value. Using this, what we have to find? Find the first term of the GP. First term is we have to find the value of A. Okay. So what is given in the question? First write the given is 6. Sum of 6 terms is equal to 46872 and given common ratio R is equal to 5 and which is greater than 1. Common ratio R is equal to 5 which is greater than 1 because based on the common ratio only we are using the formula. So what is the SN formula? We have to use summation formula. SN is equal to A into it is greater than 1. So R power n minus 1 by R minus 1 is now substitute the values given in the question. Okay, except A, all the values we know. Isn't it? Substitute them. Sn, what is Sn? Sn is here we are speaking about the 6 terms. So we can replace as 46872 is equal to A. That's what we have to find. So keep as it is. R power n. Here R is 5. N is we are having 6 terms. So 5 power 6 minus 1 by 5 minus 1. Except A, we can solve all other numbers. Okay, all other operations and find the value. How to solve it? See the next step. 46872 is equal to A into 5 power 6. 5 power 6 the value is 15625. 5 power 6 the value is 15625. If I am multiplying 5 into 5 into 5 up to 6 times, the value is 515625 minus 1 by 5 minus 1 will give you the answer. In denominator 5 minus 1 the value is 4. Now A into 15624 minus 1, so we are subtracting 1 and divided by 4. If I divide this value by 4, what is the value? 3 times x 3 times and 9 times 0 6. 3906. If I divide exactly by 4, we get the value 3906. So in this side 46872. Now, what is the line we are having? 46872 is equal to A into 3906. We want to find the value of A alone. So, A is equal to 46872 by 3906. If I divide using exactly if you are doing the division and finding the answer, so we get the answer A is equal to 12. If you divide, the answer will be A is equal to 12. If I exactly divide by this number. So, they gave the summation and they are asking us to find the first term. So choose the appropriate summation formula. Here r is greater than 1, so we chose this formula and substitute all other values except a. By solving normal, we know the normal multiplication and addition. Using the same process operation we solve and we can find the value of a is equal to 12. Okay, let us solve the next problem now. So the next problem in this exercise, find the sum to infinity. Actually, the given is a GP. Okay, we are going to check whether it is a GP. See, the common ratio 3 by 9 is 1 by 3. 1 by 3 is also 1 by 3. So it is a GP. But in the question itself, they mentioned that it is a infinite GP. It is a infinite GP. So if infinite GP means in the introduction part, I gave a formula for you. For infinite geometric progression, we have to use the formula Sn is equal to a by 1 minus r. We have to use the formula Sn is equal to a by 1 minus r. So what are the things needed here? We have to find the value of a and common ratio. So from the given series, what is the given series? We are having 9 plus 3 plus 1 plus etc. up to infinity. In this series, what is a? A is always the first value. So a is equal to 9. And the common ratio r is equal to, the common ratio is t2 by t1. That is t2 by t1, that is 3 by 9. If I simplify by 3, the value is 1 by 9. Sorry, 1 by 3. 1 3 is 3, 3 3s are 9. So the value is 1 by 3. So we got a and common ratio r is equal to 1 by 3. What is the summation formula? Sn is equal to a by 1 minus r. So a is up to infinity is equal to a. What is a? 9 by 1 minus r. What is the value of r here? 1 by 3. See, in the denominator we are having a fraction number to subtract. So whenever you are having a fraction numbers to subtract, see the denominator, if the denominators are different, you have to take LCM and then only you have to subtract the numbers, add or subtract. Now leave the numerator as it is. What is the numerator we are having? 9. So keep as it is. Solve the denominator first. If I take the LCM for 1 minus 1 by 3, here you can consider it as 1. So if you take the LCM for this, the LCM is 3. What is the LCM? 3. So if I took the LCM, 3 minus 1 by 3. So finally 9 by 3 minus 1 is 2 by 3. In denominator we are having the fraction. So to solve, just take the reciprocal. So 9 into 3 by 2. What is the value of 9 into 3? 9 is 27 by 2. So if we add this series up to infinity, the summation is 27 by 2. See the next problem. If the first term of an infinite GP is 8 and its sum up to infinity is 32 by 3, then find the common ratio. Understand the question first. What is given here? The first term of the infinite GP. Here we are speaking about the infinite geometric series. Okay, infinite geometric series. In that the first term is 8 and the sum up to infinity. If I add up to infinity, the final answer is 32 by 3. Then find the common ratio. See the previous question. They gave the infinite series, isn't it? In the question number 4, if they gave the infinite series, for that we find the summation. What is the summation answer? Here they gave the summation answer, also the value of a. We have to find the common ratio. However, I don't know the GP what it is, but we are going to use the formula Sn is equal to a by 1 minus r. Isn't it? Because they gave the summation and first value, that is a. We have to find the common ratio. So if I substitute the different values in this formula and solve for r, we will get the value of r. Let us solve it. What is the Sn summation value? 32 by 3. The summation value is 32 by 3 is equal to a. What is a in the question? The first term of the infinite GP is 8 by 1 minus r. That is r we don't know, so keep it as r. I need this value only now. X, again we came to the solving like algebraic equations, isn't it? To find the value of r. How we will solve? Just I am replacing the equation as 1 minus r is equal to 8 into 3 by 32, because we want to find the value of r only. So just I am taking to the numerator in the opposite side. So this number will be multiplied here, isn't it? 8 into 3 divided by 32. Now if I simplify by 8, 1 8 is 8, 4 8s are 32. So we got the equation 1 minus r is equal to 3 by 4. We have to find the value of r. How to find it? R is a negative, so just I'm replacing r to the next side of the equation and number to the other side of the equation. So if I replace like that, you will get the answer as 1 minus 3 by 4. 3 by 4 is equal to minus r goes there, it will become plus r. See, we are having a fraction number, so we have to take the LCM and find the answer. So what is the LCM here? 4. So 1 into 4 is 4 minus 3 is equal to r. So what is the value of r finally? R is equal to 4 minus 3 is 1 and the denominator is 4 again. So the common ratio for this infinite geometric progression is r is equal to 1 by 4. See the next problem. Find the sum to n terms of the series. Okay. Actually, this is a different problem in this exercise as well as very important problem also. See the series 3 plus 33 plus 333 up to n terms. Actually, this is not a GP. In the question, they didn't mention that it is a GP. Also, if you check 33 by 3 is 11. 333 by 33, 111 by 11. Okay, so the two common ratios are different, so it is not a GP. First, it is not a GP, but we have to find the sum of the series. What we are going to do is, we are going to do the affirmative change here and we are going to make the given series as a GP. Then we are going to apply the GP formula and we are going to solve this problem. Okay, so let us see how to do it. First, the given question, we are going to write a note first. The given question, 3 plus 33 plus 333 plus etc. is not a GP. It is not a GP. So we are going to do some changes ourselves and we are going to find the sum of this series. And we are going to take Sn. Sn is equal to 33 plus 333 plus etc. to n terms. In the first step, what I am going to do is 3 is common in this now. So just I am going to take 3 common outside. If I take 3 common outside, 1 plus 11 plus 111 plus etc. to n terms. Isn't it? If I take 3. In the next step, what I am going to do is we are going to multiply and divide by 9. What we are going to do? Multiply and divide by 9. In the next step. Isn't it? So to do these changes, so if anything multiply and divide means it won't affect the originality of the question here. Okay. So I am multiplying as well as dividing by 9. So dividing by 9 keep in common outside. If I multiply by 9 plus 99 plus 999 plus etc. to n terms. Etc. to n terms. Now if I simplify this 1 by 3. We have to divide each and every term, but I am keeping the division 1 by 9 common outside itself. Isn't it? So 3 by 9 if I simplify 1 by 3. In inside 9, if I multiply 9, 99, 999 up to n terms. Now what we are going to do is, just I am going to rewrite 9. 9 can be rewrite, 9 can be, in other words I can write 9 as 10 minus 1. Because to form a GP, every tens, hundreds, thousands will give you a GP easily, and 1 will give you easy addition and calculation. If 1 up to 100 terms means the value of 1 is 100 only. So for that convenience, I am going to rewrite the number 9 as 10 minus 1. Okay, in the first section 9 as 10 minus 1 plus. So how 99 can be round off to near 0? That is 100 minus 1. 999 if you round off to that 1000 minus 1 plus etc. to n terms. What is the next step I am going to do is, we are getting 1 by 3 as it is. Just I am going to do the 10 terms separately and 1 term separately. If I take the 10 terms, 10 plus 100 plus 1000 plus etc. n terms. Isn't it? If you are taking the 10 terms first. How many ones are there? N ones are there. So for all the 1 minus is common. So minus of 1 plus 1 plus etc. n terms. How many ones are there? N ones are there. So everyone has the minus 1, minus 1, minus 1. So I am taking the minus common. 1 plus 1 up to n terms. Now see this. 1 up to n terms. If we add 1 up to n terms, what is the value of that? It is n 100 only. Like that, if I am adding 1 plus 1 plus 1 up to n terms means the total value of the sum of the series that given is n. Okay. Now rewrite the next term. What is the value we are having? 1 by 3. 10 plus 100 plus 1000 plus etc. n terms minus n. Okay, I told that how minus n came here. That is minus n. Now the series here, the remaining series only we are having here is 10, 100, 1000 up to n terms. Think of what it is. It is a GP 10, 100, 1000 because it is a multiples of 10. Each and every term is successive term is multiplied by 10. So surely it is a GP. Okay. So just make this as equation 1, and I am just considering only the series 10 plus 100 plus 1000 plus etc. n terms. Is surely it is a GP. Is a GP. How it is a GP? We are having the A value, first value as 10, and the common ratio is also 10. See once 100 by 10 is 10, 1000 by 100 is also 10. So we are having the common ratio 10. Whenever we are adding the GP, based on the value of R, we can take the summation formula and we can add the GP. So here R is greater than 1 or less than 1. 10 means it is greater than 1. So we have to use the formula Sn is equal to A into R power n minus 1 by R minus 1. A into R power n minus 1 by R minus 1. Okay, fine. Now, substitute the value is n is equal to, what is A? 10 into 10 power n minus 1 by 10 minus 1. So, which is equal to 10 into 10 power n minus 1 by 9. So, finally, the series here we considered separately, and we got the summation of the series as 10 into 10 power n minus 1 by 9. Just replace the value in equation 1. So, equation 1 will become Sn is equal to 1 by 3, and the series summation answer is 10 into 10 power n minus 1 by 9 minus n. So, we got the final value here. Okay. So, see. First, the given question is not a GP. Okay, so I wrote as a note. The given is not a GP. If it is not a GP, means check for AP. It is not also the AP. So, however, we have to find the sum of this series. So, by doing some changes, okay, what are the changes we are doing? Means first, I am taking the 3 common outside, and we are multiplying and dividing by 9. Okay. After that, the 9 I am writing as 10 minus 1, 99 as 100 minus 1. All the 10s we are grouping separately and all the 1s. Okay. This 10 series, 10, 100, 1000 is surely a GP. And 1 up to n terms we are adding. So, the value itself as n. Okay. Just I am considering the 10 series there separately, and we are identifying that is a GP, and we know the value of A and common ratio, and we are finding the sum of that series there. After finding the summation, just replace the summation in equation 1. So, we got the total summation of the given series as 1 by 3, 10 into 10 power n minus 1 by 9 minus n. See the next problem, children. Find the sum of the geometric series 3 plus 6 plus 12 etc. up to 1536, 1536. Actually, they gave that is the geometric series, so no problem. We can use the geometric series formula, any one of the formula. We can identify the common ratio and we can substitute. But here the number of terms is not given in the question, because whatever the formula, the 2 formulas are there for you. If r is greater than 1 or less than 1, which formula we have to use? We need the value of n. They gave the last term here, but the number of terms is not mentioned in this question. So before finding the summation, we have to find how many number of terms in the geometric series, given geometric series. Directly we are not having any formula to find the number of terms. Okay, so we have to use the general term formula, and then we have to find first identify the value of n. Isn't it? For that, the given as a geometric series already given. So we can directly take the first term. What is the first term here? 3. A is equal to 3, and the common ratio R is equal to T2 by T1. That is 6 by 3. The value is equal to 2. And Tn, the nth term. Okay, the last term just I am assuming on the nth term because terms we have to find. So Tn is equal to 1536. Okay. Now the general term formula. What is the formula? Tn is equal to a into r power n minus 1. Using this formula only we are going to find the value of n. What is the nth term? 1536 is equal to a 3 into 2 whole power n minus 1. See, in this formula, except n, we know all other values. Just we are going to solve the value for n. Okay. So 1536 divided by 3 is equal to 2 power n minus 1. I can't disturb 2 without knowing the value of n here. So just I am taking 3 to the next side of the equation. Just we are going to simplify this. If I simplify this, 5 3s are 15, 1 3 is 3 and 2 3s are 6. If I simplify by 3, 512 is equal to 2 power n minus 1. Here on the right hand side, I can't change this, isn't it? Because we don't know the value, power of value n here. But we can change, make the base equal. How much I am going to change? 512 to the power of 2. We're going to write an exponential form of 2. Okay, so 519, if I am finding the prime factorization based on 2 is, the value is 2 power 9. 2 power 9 value is 512, 2 power 9. Because the base here is 12, so I am changing the next side also to the base of 2 here. Okay, so 512, if we find the exponential form, the value is 2 power 9. So 2 power 9 is equal to 2 power n minus 1. And already I told this, if the bases are equal, we can equate the power. Since the base are equal here, we are going to equate the power as 9 is equal to n minus 1. That is n is equal to 9 plus 1. We got n is equal to 10. The number of terms as 10. Okay. But here the question is not to find the number of terms, we have to find the sum of the series. To find the sum of the series, we need the number of terms. So first, we identified the number of terms. So in the given series, there are 10 terms. After this, what we have to find? We have to find the sum of the series. Is here R. Check the common ratio, whether it is less than 1 or greater than 1. 2 is greater than 1 because here the value is 2. 2 is always greater than, it is greater than 1. So we have to use the formula Sn is equal to A into R power n minus 1 by R minus 1. Is how many terms are there? 10 terms. Now what we found that the number of terms is 10 is equal to A. What is A? 3 into common ratio. What is the common ratio? 2. 2 power 10 minus 1 by 2 minus 1. A into R power n minus 1 by R minus 1. Isn't it? Now 3 into 2 power 10. What is the value of 2 power 10 is 1024 minus 1. If I am multiplying 2 for 10 times 2 into 2 into 2, the value is 1024 minus 1. So 3 into 1023. If I subtracting 1023, multiply by 3. If I multiply by 3, 3 is 9, 2 3 is 6, 0, 3. So 3069. Isn't it? See, 3 3 is 9, 2 3 is 6, 0 and 3069. So the sum of this geometric series up to 10 terms is 3069. See the next question. Find the rational number, rational form of the number 0.123. Actually, the question is given in the form of decimal. Also, it is a terminating decimal. Okay, we have to find the rational form of this question. How using the GP geometric series we are finding the rational form of this question. How we are going to find? See, first the given number here, the decimal number is 0.123. That means if we expand this, we can write it as 0.123, 123, 123. It will be going on like this. That's the terminating symbol they gave on the upside of the number, isn't it? So this number can be expanded like this. 0.123, 123. It will be going on like this. So this number, how I can write in the form of series? How? See, the first number can be written as 0.123 by is plus 0.000123 plus 0.123 plus etc. Just I am expanding this number in the form of series. That is 0.123 plus 0.0002 plus 0.6013. So if I add this series, surely we will get the above value here. Okay. Now, how we can rewrite this number? This can be written as, I am going to remove the decimal form. Okay, just write it in the fraction form. That means how we can write as 1 to 3 by 1000. Because 3 decimals are there now. Plus 1 to 3 by 1, 2, 3, 4, 5, 6. Because 6 decimals are there. Plus 1, 2, 3 by how many decimal points are there? 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus etc. We can write like this. The number in the form of decimal. Just I am taking to the fraction format. Now, how can we write? By 1000 can be written as 10 cube. Plus 1, 2, 3 by how many zeros are there? 6. So 10 power 6. Plus 123 by how many zeros are there? 9. So 10 power 9 plus etc. up to infinity. It will be going on like that. So in the question, if it is not infinity also, it will be going on like that 1 to 3 only. So automatically it comes under the condition of infinity only up to infinite terms. Okay. Now check whether it is a GP. See 123, 123. We will check once. Okay. The common ratio. If you are going to check the common ratio, T2 by T1. What is the second term here? 123 by 10 power 6. By the first term is 123 by 10 power 3. Isn't it? If we simplify, 123 and 123 will get cancelled. The remaining is 1 by 10 power 6 by 1 by 10 power 3. If I take the calculation to the reciprocal, 1 by 10 power 6 into 10 power 3 by 1. If I simplify again using the power, the value is 1 by 10 power 3. Okay. Check for the next term also. 123 and 123 will get cancelled. 10 power 9 minus 10 power 6 again we will get 1 by 10 power 3. So surely what we are getting here, it is a GP. So this infinite series is a GP. With the common ratio. What is the common ratio? 1 by 10 power 3. And what is the value of A we are having here? What is the value of A? A is equal to 123 by 10 power 3. Okay. And R, common ratio is equal to 1 by 10 power 3. I told that it is a infinite GP. If we say infinite GP, what is the summation formula we have to use? Sn is equal to A by 1 minus R. Sn is equal to A by 1 minus R. Substitute the value. What is A? 123 by 10 power 3 by 1 minus 1 by 10 power 3. Just expand the value. So 123 by 10 power 3 is 1000 by 1 minus 1 by 1000. 1 minus 1 by 1000. If you expand this value, what is the value we are going to get? C, which is equal to 123 by 1000. In the denominator, if I take the LCM and if we are subtracting, the value will be 999 by 1000. See how? If I am taking the LCM is 1000. If I multiply with this, 1000 minus 1. 1000 minus 1 is 999 by 1000. So just we are having two fractions here. 1000 and 1000 will get cancelled. The remaining is 123 by 999. If we simplify by 3, we will get the answer as 4 3s are 12 and 1 3 is 3 and 3 3 3. After this, it cannot be simplified. So 41 by 333. Thus, for the rational form of 0.123, the terminating number is 41 by 333. That is the rational form of the given number. Okay, children. Is the last problem in this exercise, children. Sn is equal to x plus y plus x square plus xy plus y square plus x cube plus x square y plus xy square plus y cube plus etc. n terms. They gave some value for the summation. What we have to prove is x minus y into Sn. If you are multiplying x minus y into the value of Xn, we have to get the value of this. Okay, how to find this? First, we are going to take the LHS and we are going to prove the RHS value here. Yes. So we are having x minus y into Sn. That means x minus y into Sn. Sn for Sn in the question they gave the value. What is the value? X plus y plus x square plus xy plus y square plus x cube plus x square y plus xy square plus y cube plus etc. n terms. Isn't it? Now, if I multiply xy inside that, okay, because we are having a graph x minus y into Sn. If I multiply inside that, xy will be multiplied with each and every term of this Yes, sir. X, if I multiply, we will get x minus y into the first term, x plus y, plus of x minus y into the second term, x square minus xy plus y square, plus x minus y into x cube plus x square y plus x y square plus y cube plus etc. n terms up to the n terms. Now see, x minus y, we are multiplying with each and every terms of Sn here. Recall once by seeing this multiplication. See the terms x minus y into x plus y. Using algebra, you can recall one identity here. What is the identity? A minus b into a plus b. See the second term, x minus y into x square minus xy plus y square. What is the identity? This in algebra. A cube minus b cube. Yes, very good. The final, what is the formula you remember in algebra? A power 4 minus b power 4. Just here it is in the form of x and y. So each and every product here is an algebraic identity. Okay. So what is the first algebraic identity? X square minus y square plus the second expansion. The algebraic identity is x cube minus y cube. What about the last one? X power 4 minus y power 4 plus etc. n terms. They are in the form of product, but the product itself resembles directly. It indicates the algebraic identity. Just we are replacing as the algebraic identity here. The first one is x square y square. Second one, if the product gives you x cube minus y cube, this product gives you the formula x power 4 minus y power 4. Now, however, we have to prove the value there. For that, what I am going to do is, we are going to take the x terms separately and y terms separately. If I take the x terms, all the x are in plus. So, x square plus x cube plus x power 4 plus etc. n terms. All the y are in minus, so minus of. This is a separate series. Minus of y square plus y cube plus y power 4 plus minus and taking common plus etc. n terms. So we are having here, after segregating like this, here we are having two series. One is in the form of x, other one is in the form of y. Check whether the two series are in GP. First go to the x series, isn't it? X square, x cube, x power 4. Okay. If I take the series, see each and every value, the successive value is multiplied by x. So surely it is a GP. What is the A here? For x series, what is the A here? A is equal to x square. The first term is x square. And the common ratio, R is equal to, each and every value is multiplied by x, so R is equal to x. For the y series, if I am checking for the y series, the A, the first value is y square and the common ratio R is equal to y. So surely this is a GP separately and this is a GP separately with different common ratio. Here the common ratio is x. Here the common ratio is y. So surely we can use the summation formula of GP here. If we use the formula, Sn is equal to, what is the formula we are going to use this? In general, know the formula as Sn is equal to A into R power n minus 1 by R minus 1. Isn't it? Here up to n terms only, so keep n as it is. Substitute all other values here. For x, if I am substituting for x, what is the first one? A into, what is A? X square into R power n. What is R? X power n minus 1 by x minus 1. In middle it is minus of, right further, x to c is the answer. Again we are going to use the same formula. What is A here? A is equal to y square and common ratio R is equal to y. So if I am replacing y square, y power n minus 1 by y minus 1 is what you have to see in the question. X square into x power n minus 1 by x minus 1 minus of y square into y minus y power n minus 1 by y minus 1. Okay, so this is a very simple problem. The question is a little bit different, but it is very simple. Just if you get the product inside, every product will give you the algebraic identity. Just segregate the x terms separately and y terms separately. The x series separately forms a GP and y series separately forms the GP. For x series, identify the A and common ratio. For y series, identify the A and common ratio. Use the summation formula. Okay, use the summation formula. Just substitute the value. We got the RHS here. So we proved the problem. Okay, with this we have completed the exercise 2.8 children. So geometric progression is in 2.7. We we seen about the geometric progression. Here we discussed about the geometric series. Okay. So based on this, you can work out all the example problems also. Okay. Don't do any example problems. Based on this, you can work out all the example problems. Okay. Next, we'll see the 2.9 exercise in the next section. Thank you, children.